Hi, in this video we're going to look at the topic of arc length and sector area of circles. This is a GCSE Higher topic and will appear both in the A star to G GCSE exams as well as the new 1 to 9 exams. If you need any more advice, as ever you can contact me on Twitter at Mr_G_Walton or our school account at Tupton Maths. So in this particular video what we're going to be looking at is this idea of calculating the length of an arc of a circle if you're given an angle. Okay, this is going to be important. We're always going to be given an angle to be able to do these things. Alternatively, you might be given an arc and asked to work out the angle. So, that reverse process that you're often asked to do in maths. We're also going to look at the area of a sector, and to be able to use both of these skills in these more complicated multi-step problems if it's combining some other maths knowledge as well. Okay, first of all, let's take a look at what we're talking about. In this first example, you can see that we've got a part of a circle. Now, before we do anything else, let's just double check that we're confident in terms of the language that we're using here. So first of all, we need to see this part of my circle here. Notice this is not the whole circle, but it's a part of the circumference. That's called the arc. Okay, so this part is called the arc. In terms of a sector, then what we're really looking at is this blue section here. Okay, so again, a part of a circle in terms of its area is the sector. Now we're going to look at calculating both the arc length as well as the sector area here. But first of all, we have to remember our two key facts about circles, and that's how to work out circumference. So circumference is pi times diameter, and area is pi r squared. You might have seen that in one of my other videos as well with a little circle song. It's very catchy, really easy to remember. So circumference is pi times diameter, area is pi r squared. Okay, let's see what we've got here then. Well, we don't have the whole circle. And that's the first thing that we notice. Because we don't have the whole circle, what we do have is just a part of it. Notice we've got 150 degrees of it. Again, if you've seen my subscriber special video, you'll notice that we talk about this really special way to calculate parts of things, and we're going to use it exactly here. We're going to talk about 150 out of the whole thing. Now we know that that's 360 degrees. Okay, so we've actually got this proportion, this fraction of the amount, 150 out of 360. And whatever it is that we're trying to work out, whether it's the arc length, if it's the arc length, then we're going to multiply this proportion by the circumference of the whole circle. And if we're finding the area, then again we're going to use this proportion, this 150 out of 360, and we're going to multiply that by, in this case, the area, because we're wanting the area of just the sector. So if we wanted the area, then this is how we can do it. So this top bit will give us the arc length. Oh, we've run out of space. And the second one will give us the sector area. So this will give me my sector area. Okay, let's see if we can work both of these out then. First of all, we're going to have to work out the circumference, then we're going to have to work out the area, and then finally we'll work out our arc length and sector area for this particular question. So let's have a look at our circumference then. Well, remember the circumference is pi times diameter. Again, little tip here, make sure that you remember that this is the radius and not the diameter. So you're going to have to double these. So we've got circumference is pi times diameter, so pi multiplied by 26, or 26 pi, and I'll get an answer on my calculator for that bit. For this area part, again, what we're saying is we've got pi multiplied by 13 squared. Again, if I can just give you a little top tip at this point, make sure that you're squaring 13 before multiplying it by pi, and then you're not doing 13 times pi and then squaring it. If you find yourself getting lots of wrong answers, it could be because you're doing that. Okay, let's actually get some answers, and I'm going to type these in on my calculator. So for the first one, I've got 81.68 centimetres, 81.68 centimetres, plus a little bit more. Now technically what I should do is make sure that I'm using my whole number all the numbers that appear on the screen before working out this proportion down here. Okay, so I will do that when I'm working out mine. If you just type in 81.68, you might get a slightly different answer to me. Otherwise, that's why. So let's work out the area as well. So I've got this, which gives me 530.929. So 530.929, so on and so on, that's centimetres squared. Okay, so if I want to work out the arc length then, this part, I'm going to make sure I'm using this bit of my circumference. Okay, so I want the circumference, but I don't want the whole of it, I just want this proportion of it, the 150 out of 360. So again, I can do that on my calculator, 150 divided by 360 multiplied by, and just for accuracy I'm going to multiply it by 26 pi on my calculator, but as I say, you'll be writing all these values down on your exam sheet. And I get a solution of 34.033, I'm just going to round it at 34.03 centimetres. Remember, it's a length that we're calculating. Let's do the same thing for our sector area then. Again, we've got 150 divided by 360, and then we're multiplying it by the whole area of the circle. So I'm just finding this fraction, this proportion of the whole area, which we said was 169 pi. So I've got 221.22. So 221.22 centimetres squared. Notice I've rounded mine to 2 decimal places. You'd have to read exactly what the question was asking, whether it wants 2 dp or 3 significant figures, whichever. Okay, let's move on to look at an actual exam question then. Notice this one, it shows a similar kind of picture to what we had before. We've got an arc length here, we've got a sector shown, we've got an angle here. It says the diagram shows a sector of a circle, centre O. The radius of the circle is 6 centimetres, we can see that. Angle AOB is 120. Work out the perimeter of the sector. Okay, so this is slightly different, but in effect what we've been asked to do is to work out this curved part here for the arc length, plus these 2 lengths here. Remember, the perimeter's all the way around. So the hardest bit is to make sure that we've calculated the curved area. Once we've calculated the curved, we can add on these 2 lengths at the end. The final thing says, give your answer in terms of pi in its simplest form. So there's a good chance that this might appear on a non-calculator paper. So this time I'm going to try and do it without our calculator and just leave it in terms of pi. Okay. So first of all, what we're going to have to be thinking about is working out our circumference of the whole circle. I'm not interested in the area this time, I only want the circumference. So circumference is pi times diameter, here we go, pi times diameter, which will give me in this case 12 pi. C equals 12 pi. Now, I'm not trying to work out what this is. Notice that I'm just referring back to the question. Give your answer in terms of pi in its simplest form. So I don't need to do anything else here. The only reason I've put the 12 at the beginning and the pi at the end rather than pi 12 is just for neatness and standard convention. If we have a mixture of numbers and symbols, we tend to put our numbers at the beginning and our symbols at the end. Okay, what else do we need to do? Well, we also now need to not have the whole circumference, but just a proportion of it, a fraction of it. And the fraction that we want is 120 out of 360 multiplied by 12 pi. Okay, so this is going to be calculating just this bit of my arc length here. Okay, still have to remember we've not done anything with these 2 straight lines just yet. Okay, let's work this out then. So 120 out of 360, we can cancel that down straight away, and that looks like we can cancel those 2 zeros, which means I get 12 over 36. Again, cancelling this down further, I'll end up with a third. So a third of 12 pi. Again, I use the word of specifically at this point, remembering that of and multiply are often interchangeable within maths. So a third of 12 is 4 pi. So the length of my arc here is 4 pi. Now, I don't need to again work it out, I want it in terms of pi, so we've got 4 pi, and we also need to remember now it's the perimeter we're finding, so we need to add on these two lengths as well. So I end up with 12 plus 4 pi centimetres. Brilliant. Okay, so notice we didn't use our calculator at all. We weren't concerned about it, even though quite often circle type questions do appear on calculator papers. Make sure that you're comfortable in terms of doing things like this, just in terms of pi. If anything, it's probably a little bit easier. Okay, let's look at our final example. In this final example, we are going to apply these skills that we've been using then. So again, we'll read through the question carefully. We can see we've got a picture here. We can see we've got a grey bit. I think we can almost, without reading the question, we know what's coming, but let's see. ABC is an arc of a circle centre O. So ABC, here's my arc, with radius 80 metres. AC is a chord of the circle. Angle AOC is 35. Calculate the area of the shaded region. Give your answer correct to 3 significant figures. Okay, well, area of the shaded region. I'm going to have to use a little bit of clever skills here, I think. What I'm thinking in my head is I could work out the whole area of the sector. That's fairly straightforward. Can I work out the area of the white triangle to take that away from the area of the sector, just leaving the grey bit left behind? Okay, let's see if we can do that. Before we start worrying about this triangle, let's do the whole sector area. And you should think about this in your exams too. Even if you can't get the whole solution, at least make a step towards doing the right thing. You're going to pick up marks. So we remember that sector area, we are going to work out the area of the whole circle. So area equals pi r squared. So we know our radius is 80. So area equals pi multiplied by 80 squared. Area equals. And I'm just going to do this bit on my calculator. And I'm going to write it down in terms of pi first, because that's going to be more accurate. And again, just for maximum points in my, or possible points in my exam, I'm also going to write down the whole display on my calculator. So 0.19298. 8. Just about squeeze it on. Okay, now we've worked that part out. What's next? So next what we need to do is think about, that's the whole circle. That was the whole circle. What we need to do is to calculate our just small part of it, which is 35 degrees out of the whole thing. So we've got 35 out of 360 multiplied by 6400 pi, and that can tell me the whole sector area. Okay, so the whole sector area, which is giving me 1954.77 meters squared. Okay, now at this point I'm not overly worried about the accuracy, because my final answer wants to be correct to 3 significant figures. I've got 5 here, okay, so I'm not overly concerned. The bit that I've got here though is the whole sector area. What I need to do is take away the white part. Now again, this is an extra added skill here. I'm hoping that you've spotted that we can use our trigonometry here to use the area of a triangle, which is a half AB sine C. If at this point you don't know how to do that, don't worry too much. That's something that you can learn over time. But at this point, this is what we're going to use. We're going to use a half AB sine C. I'll just adjust my slide slightly. Okay, here we go then. So we've got, for the triangle area, we want, let's just change colour. So the triangle area, we're going to use a half AB sine C. Okay, which is a half times, call this A, 80, times B, so another 80, multiplied by sine of the angle which in this case is sine 35. Okay, let's see what we get here then. Again, I'm using my calculator at this point, and we've got an answer of 1835.44. 1835.44. Again, meters squared. Now, what I would always encourage you to do at this point is just to make sure that that makes sense. I'm looking at my whole sector area, 1954, that's everything. This triangle is working out at 1835. That seems reasonable. I've only got a bit left. So the final thing I need to do is to work out the sector, the shaded region, sorry. So the shaded part is 1954.77 minus 1835.44, and that should leave me with whatever I've got left. Okay, again, let's just do that on our calculator nice and quickly. 1954.77, take 1835.44, gives me 119.33, so 119.33, but we want our answer correct to three significant figures, so that leaves us with 119 meters squared as our final answer. Lots of opportunity to pick up marks in these sorts of questions, even if you don't get to the final solution. So notice we worked out the area of the whole circle. We then worked out a proportion of it, so our sector area. We then worked out the area of a triangle using half AB sine C. Then the final part was to take the two things away from each other to leave us with a shaded area. So I'll say lots of opportunity to pick up marks even if you don't get to the final solution. Obviously that's where we want you to get to, but if you feel that you're in an exam situation you can't do it all, at least pick up some of the bits as you go. Final thing then, this is a question that I'd like you to have a go at by yourself. Read the question, pause the video, and I'll show you how to do it in a few minutes. The part that I'd like you to work out is the shaded area here. I know it doesn't say it in the question, but that's what I want you to work out, the shaded area, okay? Right, very similar to the last question then. So what we are going to have to do is to work out the area of the whole circle first. So area equals pi r squared. So that is pi multiplied by 10.4 squared, which gives me 339.79. Again, we'll go for three significant figures here, so I'll make sure I've got enough centimetres squared. I don't want all of it, I only want a proportion of it. The proportion I want is 120 out of 360 of this that I've just worked out, which is going to give me, I'm doing this at the same time that you are, so 113.26, and that's the whole of this sector area. We now need to take away the white triangle part, which again we're going to use half AB sine C. Little tip here, make sure your calculators are showing in degrees mode, not in radians, otherwise you're going to get a different answer at this point. So we're going to do a half times 10.4 times 10.4 multiplied by sine of the angle, which is 120. Okay, which gives me 46.83 centimetres squared. Should have put my centimetres squared on that bit as well, that was a little bit naughty. And so my final answer then is 113.26 minus 46.83, which leaves me with 66.43 centimetres squared. Okay, perfect. Hope you got that solution as well. Let's move on to the final part, which is where we take some revision card notes. The key to this is just remembering that we're finding this proportion of the whole thing. So always start out where you're working out either the circumference or the area of the whole circle. Read the question carefully to see what it is that you're being asked to do. You might also need to link in a little bit of triangle work. The triangle work that you might be asked to do is the area is a half AB sine C. We're also, things that we're looking at is the proportion, the part of the angle that you're looking at out of the total, and we might be multiplying that either by the circumference or the area of the whole circle. Okay, it's as simple as that. I say it's simple, it's just a case of working out step by step. The bit that makes it difficult, I guess, is that you've got lots of things that you need to do, and you're combining lots of skills again. Otherwise, hopefully this has gone well and you found it useful. Please leave me a note to say so if you have, or if you haven't and you want something else doing instead, I'll happily do that too. Okay, thanks, bye.